Alright guys, so today we're looking at the mean value theorem, and we're going to talk about how is the mean value theorem different and how can it be used for some similar type of proofs as the intermediate value theorem and when to use each. So earlier in the year we talked about intermediate value theorem, and let's just recall that. The intermediate theorem just states that if f of x is a continuous function, so look down here at my function here, we see that it's continuous, there's no breaks, over the interval a to b, then there exists a point between a and b that the output d such that f of c equals d. So all that means here is that between a and b, between points a and b, so we have a and f of a, and then we have b and f of b, we know that if this is continuous, there exists such a point that d is going to be between the outputs f of a and f of b, and that c is going to be between the inputs a and b. And we can look right here on our graph that we know that there does exist a point such that there's a value that's greater than a but less than b, and an output that's greater than the output of a but less than the output of b. So for example, this guy right here would not satisfy those conditions, but this guy would. The mean value theorem is very similar to that, but all it's doing is it starts talking about, we know that mean means average, and all that it means between that is that we're talking about rate of change. So very similar to the intermediate value theorem, we're making an assumption that there's a point that lies between, but this is talking about slopes. So it says that if our function is differentiable and continuous over the interval ab, then there's at least one number c such that that is equivalent to the slope between point A and B. So that seems a little funky, but all that means is that if you take two values, A to B, and we know that whatever the slope is, let's call it -1/2. So let's just say m equals -1/2. And if that is continuous and differentiable over that interval, then there does exist a point such that the slope at that other point is parallel to the slope that exists between those 2 points, kind of like that squeeze theorem. There's something in between that has the exact same value. So let's see how we might apply these things and where do we use either one. Our first question here says let f be a function that is differentiable on the open interval 1 to 10. If f of 2 is -5, f of 5 is 5, and f of 9 is -5, which of the following must be true? All right, so let's get going. Number 1 says f has 2 zeros. That's going to be intermediate value because a 0 is talking about a value. Let's look at number 2. Tangent line, that's going to be the mean value theorem. Mean value theorem. Because we're talking about tangents or slopes. And then number 3 says that there exists a point, so that's a value or an intermediate value theorem. So let's start doing this. Number 1, 2 zeros. So let's look at our points here. We need to use some intervals. I see that if I just use 2 to 9, that's not going to give me any good information. So I'm going to say let's use the intermediate value theorem from 2 to 5. And from 5 to 9. Because from 2 to 5, we have the value 2, -5, and 5, 5. We know that there has to be a 0 between these 2 points because it's differentiable and continuous over that interval. And on the interval from 5 to 9, we have the point 5, 5, and 9, -5. So the intermediate value theorem states that there must be zeros that fall between both of those. So number 1 is true. And if this were free response, you could just say we use the intermediate value theorem over these 2 intervals. Now let's look at number 2. The graph of f has at least one horizontal tangent. So now we're looking at instantaneous slopes. So let's use the interval. Horizontal means a slope of 0. So I'm going to be kind of picky when I choose the values I'm using. Let's do, so we want m to equal 0. So that's part A. We're thinking m equals 0. So I'm actually going to use the mean value theorem over the interval 2 to 9. And the reason why is because that gives us the ordered pairs 2, -5, and 9, negative 5. And when I perform that slope, that y2 minus y1 over x2 minus x1, or f of b minus f of a over b minus a, I get negative 5. I'm going to say that f of b minus f of a over b minus a equals negative 5 minus negative 5 over 9 minus 2 equals 0 over 7, which is 0. So yes, that is true. And what you could say is mean value theorem over this interval. And if it were for your response, I'd probably show that work right there as well. So we can give ourselves a check mark here. Which means that we are not that. Okay, let's look at this very last one. For some c from 2 to 5, there exists a point f of c equals 3. So back again, intermediate value theorem. So we need to state what theorem we're using first. Now it's giving us a specific interval to use, so over the interval 2 to 5. If I look at f of 2, it's negative 5. If I look at f of 5, it's positive 5. We know we want 3. We know that 3 is between those two, so all I need to say is f of 2 is less than f of c and greater than, less than f of 5, greater than f of 2. So there does exist a point right here. Wow, I really messed that guy up. There does exist a point here that is going to be between those values. Because 3, all we're saying is 3 is between negative 5 and 5. And you don't need to put all of that. What you would need to say is we use the intermediate value theorem between those 2 points. And f of 2 is all this information, speaks to let us know that that value, 3, is going to be between. So all these are true, which means that E is the correct answer here. All right. So now that we kind of talked about how we would start formatting that like an AP test question, let's look at an actual AP test free response. Well, that was AP, but it wasn't free response. So let's look at this guy here. The functions f of g are differentiable for all real numbers, and g is strictly increasing. The table above gives values for the functions and their first derivatives at selective values of x. The function h is given by h of x equals f of g of x, decomposition, minus 6. So A says explain why there must be a value r for 1 through 3 such that h of r equals negative 5. So right here we're looking for intermediate value theorem because we just want a value. So let's come up here and go to the left so we can have some room. So because this would be free response, we need to make sure we're showing our work thoroughly. So let's do IVT, and we're doing the interval 1 through 3. So let's get this written down. I know h of 1 and h of 3 is going to be f of g of 1 minus 6, and this is f of g of 3 minus 6. And we can just solve this guy out here. G of 1 is 2. F of 2 is 9. So we have 9 minus 6, which is positive 3. G of 3 is 4. And then f of 4 is negative 1. So we have negative 1 minus 6, which is negative 7. Okay, so cool. We know in our brain that there has to be a value, but let's format it correctly. We're going to say here that we know that h of 1, we're going to use h of 3, is negative 5, is going to be between these two values. Oops, negative 5. Come on. Negative 5 is between these values. And if you put the h first, so if you rewrote this to where h of 1 was first, just make sure you're checking your inequality symbols, that they are correct. Because I know that negative 5 is between these two outputs, you can say that, according to IVT, there exists a point R or R is a value between 1 through 3 because of all this information that we did up here. It does not want to let me do that negative. And this is what you would need to be writing on the AP test to get you full credit. This work right here will be supplemental and also give you credit. All right, let's get part B. Explain why there must be a value C for one C is between numbers 1 and 3, such that H prime of C is -5. All right, now we are looking at mean value theorem for this guy right here. So let's get this done. We're looking over the interval 1 to 3, mean value theorem. So we need to know what is H of 1 and what is H of 3. All right, so H of 1, we've already done this, so we can just write this down from our previous. We know that H of 1 is 3 and that H of 3 is -7. So then I can just start doing according to the mean value theorem. So let's do that slope. We have H of 3 minus H of 1 over 3 minus 1, which is equivalent to -7 minus 3 over 3 minus 1. -10 over 2, which is -5. All right, so this would be half the work, or half the credit would come from actually saying these two guys right here. We evaluated this guy right here. So now that we have the work, we have to draw the conclusion. So we say according to the mean value theorem, we know according to the mean value theorem, since H, function H, is continuous and differentiable, there exists a point C such that H prime of C equals -5. So things that are really important here is that we have to name according to the mean value theorem. Because it's talking about slope, we have to name continuous and differentiable, and we have to also name that there is that point that exists right there. Everything else is kind of just like fluff. All right, so let's get this last guy done. Let w be the function given by w of x is the integral from 1 to g of x of f t dt. Find the value of w prime 3. All right, we know that when we do derivatives of integrals, so dx, it essentially cancels the integration out. So what this means is that w prime of 3 is going to be the same thing. This needs to get plugged in. Because it's a derivative of an integral, this value, this f of 1, is just going to be a number. So that is going to have a derivative value of 0 because it's a constant. So we're just going to leave that out of there. So we know that this is f of g of 3. But because we took that derivative, remember when we integrate, we still have to take into account like whatever transformation happens here. So I'm multiplying by that chain rule of g prime of 3. Now it's not f prime because that integral canceled out the derivative, but we still have to say like what's going on here and cancel that out because that is a transformation that's occurring. So all we're doing at this point is just plugging in values. We have f of 4 times 2 according to the values in my charts, and then f of 4 is -1 times 2, which gives us -2. Things that count on the AP test are that you realize that this is here and that constant gets canceled out and that you're left with a value of -2. And that's it, guys.